There we go. Okay. This one will work okay.
Just how old is the things in our universe, like the moon?
Testing, testing. 1, 2, 3. Are we good? Okay. Well, the regular headset mic battery's dead, so we'll see how this works. All right, so how many of you have been to one of my presentations before? Oh, wow, most everyone then. You're the regulars at this point. But I see there's like 1 or 2 people that haven't been here before. So, by way of introduction, I am Ellie Husband from Alpha Omega Institute out of Grand Junction, and I've been doing a series of presentations over the school year on various topics. Can those of you who are regulars tell me what some of those topics have been? Mm-hmm. Yep. Mm-hmm. Yep. I can think of 1 or 2 more. Yeah, creation all the way to Tower of Babel. There's a lot of topics packed into that one. So this is actually, now we're within the last couple presentations. So after this one, I have 2 more coming up, if you can believe it already. We're within the home stretch here. So the 2 that are coming up is the one in March on design in God's creation. We're going to look at like the engineering of his of life, creatures and plants and animals, and how it shows that there's evidence for a creator. And I'm even going to talk about a new model that creation scientists have been putting together that explains the diversity of animals in our world better than natural selection. So that'll be interesting. And then the very last presentation I'm doing in April is gonna be all about, I know there was 1 or 2 of you that took an environmental science class a couple of years ago. I'm basically going to be diving right into the middle of that topic. So, okay, what about all this climate change stuff, environmentalism stuff? How do we as Christians answer those issues? So that'll be my last presentation, and I hope it will be very enlightening on that point. But without further ado, let's get started. So, astronomy and cosmology, a biblical perspective. So, I will say this before we get started. Astronomy is a huge field with a lot to talk about. I am just skimming right over the surface in this presentation. If you want to ask more questions or get more information, you can ask me afterwards. I can direct you to some resources. But just realize I'm going right over the surface, so I'm going to touch on a lot of things very briefly. So with that, come on. Is my clicker not working? Technology. Gotta love it. Troy, can you press the arrow key? See if that works. There we go. All right. So, before we get into anything related to the night sky and, the heavens above, we gotta talk about the 2 competing theories within the sciences. And yes, evolution, the theory of evolution versus the theory of creation, it extends up to the stars and planets too. Let me try adjusting my position. Oh, so most of the time when you hear about evolution, the theory of evolution, it's within the context of biological evolution. So it's the idea that like animals progressed through different types or kinds into another kind of animal, like reptiles to birds, for example. But there's two other types of evolution that are kind of fit within this whole term. And that is chemical evolution and stellar evolution. Chemical evolution is, well, how did we even get the first life form? And it goes into the theories about the very distant past of life. What I'm going to be touching on today is stellar evolution. So this is the idea that it wasn't just living things that, in a sense, created themselves out of natural processes over billions of years, more like millions in the case of living things, but that the universe itself basically created itself using only the laws of physics over about 13.8, I think is the number right now, billion years. So that's stellar evolution, and that includes things like the Big Bang, stars forming themselves supposedly out of what's called planetary nebula, and so on and so forth. So when I talk about evolution in this presentation tonight, this is the type of evolution I'm talking about, not biological. So with that clarification, okay, this is really becoming a problem. Anyway, so yes, the Big Bang is probably the most commonly known expression of this idea of stellar evolution. On the other hand, there's another explanation for how we got a universe in the first place. And that is, well, the universe was created by God 6,000 years ago, as attested to in the first 2 chapters of Genesis, especially the first. But everything in the universe was also created by him. So whether it's non-life or life, everything fits within, this idea that it all originated within the first 6 days of creation. That's the contending theory. Now, you can't have a creator God making the universe in 6 days and a Big Bang making the universe with no mind behind it 13 billion years ago. Both cannot be true. Either one is true or the other is true, not both. And thus is the contest. So, usually, the Big Bang is presented as the science. On the other hand, the story of creation, well, it's just a story. It's just a religious fable. But is that really the case? Science or religion? Okay, this is really a problem. So let's talk for a minute about what exactly we mean by science. Observational versus historical or forensic science. Now, observational science is the study of things that are in the present. It's the stuff you can touch, see, etc. Troy, can you move the slide, or is it frozen? Oh, okay. For some reason, my clicker doesn't seem to be working at all tonight, so sorry, Troy, I guess you're my clicker now. So on the other hand, historical science would be like archaeology or paleontology. You don't know what happened in the past. You're making your best guess or inference as to what may have happened in the past to get what we have today. So, as I said, observational science uses the scientific method: test, observe, repeat. It asks the question of what? What is present? What is in front of me? What are we measuring? All right, continue. You do experiments to gain facts or data, and ultimately it asks the question of what? On the other hand, historical science, you can't run experiments on the past. You can't travel back into the past. So, what can you do? Well, you ask the question of how, why, and when. It's all the other questions. Oh yeah, scientific laws are an example of observational science. Also, is the slideshow having issues or... Okay. All right. Now, historical science uses information from observational science. So observational science gives you the pieces of the puzzle that then you're trying to put together into a sensible picture. So, yep, educate guests about things in the past. Interpretation of data, that's the important part. You don't gain data from historical science. You interpret the data through historical science. And it asks the question of how, when, why. So, an example of this is, next slide please. This. What is this shape that you see? Well, it's two lines that don't quite meet, right? And they're black on a white background. That's observational science. You could measure those lines, you could, do a detailed study of that shape. But as soon as you try and say, well, is that a broken circle? Then you're going into historical science. And sometimes what you may think is the obvious answer is not, in fact, the correct answer. Next slide. Next slide. For example, that shape you just saw could be any of these options. Or none of the above, but something else entirely. Or it could just be what it is, and it's not broken to begin with. That's the difference between data versus interpretation. Observational science versus historical science. Next slide. Data, fact versus interpretation. So, what we're really looking at here is two theories about the past. They're both forms of historical science. We're trying to take the same Earth, the same world, the same universe, the same stars, the same galaxies, and figure out how we even got them in the first place. Why are they here? Two competing theories. One is not inherently more scientific than the other. Next slide. The facts are the same, the interpretations are not. Next slide. So, which interprets the data best? That's what we'll be answering in the rest of this presentation. Next slide. All right, so let's first talk about astronomy versus cosmology. Now, usually when people get introduced to astronomy, especially when they're in high school, like when I started really going into astronomy, I very quickly got thrown into the deep end, all sorts of weird and wild stuff. And it turned out they were actually teaching more of a cosmology than astronomy. Why is that? Well, next slide. Astronomy is the study of objects and matter outside the Earth's atmosphere and of their physical and chemical properties. In other words, anything else not here, not on Earth, not within our sky, that's astronomy. So whether it's space dust or asteroids or moons or planets or stars or galaxies or comets, anything, that's astronomy. So it's actually a really, really big field. Some examples of things that would fit within astronomy are the moon and the sun. Continue. Comets and asteroids, planets, and stars and galaxies. Though, as I said, there are many more things that go under this particular field. Cosmology, on the other hand, is a little harder to define. It can be one of three different things. It's either a branch of metaphysics that deals with the nature of the universe. By the way, metaphysics is actually a type of philosophy. So we're not really in science anymore, guys. It's also a theory or doctrine describing the natural order of the universe. Theory or doctrine? Interesting. So what you're telling me is you could have a scientific theory that's a cosmology or a religious doctrine that's also a cosmology. Answer yes. It's also a branch of astronomy that deals with the origin, structure, and space-time relationships of the universe. If you open up an astronomy textbook in high school, they're usually diving into the third definition right out of the gate. And you don't even realize that cosmology is actually less of an observational science and more of a historical science that yet also has more than a foot in philosophy. So, cosmogony is the specific, like, the cosmology that deals with the beginning, the origin of things. So, it's a theory of the origin of the universe. It's the creation or origin of the world or universe. So technically, the Big Bang, 6 days of creation, they are ultimately, at their core, cosmogonies. There's a word for your vocabulary list. So, now, let's take a look at something a bit closer to home. The solar system. Let's see. Next slide. Oh, that was it. So, if you're familiar with the 6 days of creation, first day, light, darkness, second, division of waters, third, land, and then fourth, the creation of the stars, the moon, the planets, the sun, all the things that astronomy deals with, basically. According to the creation model, those were all made within 1 day, not over billions of years. So, as stated in Genesis 1:15-9, God said, "Let there be lights within heaven to separate the day from the night, and they shall serve as for signs and for seasons and for days and years, and they'll give light on the earth." In the case of the sun and moon, they definitely give light upon the earth. In the case of the stars actually were used for many thousands of years to help determine the time. So you could actually determine what month you were in and what part of the year, what season you were in by looking at the sky. People used to do that. Even up into the 19th century, people kept that knowledge of how to read the sky in order to know where they were in the year and in the month. It's a lost art because we have things like clocks and, calendars on our phones now. We don't have to do that anymore. So, God made the two great lights, the greater light to govern the day and the lesser light to govern the night. And he made the stars also, just an aside. You'll find out how much of an understatement that is later. So God placed them in the expanse of the heavens, or the universe, the sky, to give light on the earth and to govern the day and the night and to separate the light from the darkness. And God saw it was good. And there was evening and there was morning, the fourth day. So everything I'm talking about tonight, mostly, fits all within 1 day out of the creation week. So, made on day 4, sun, moon. That's a close-up picture of the sun with the light way dimmed down so you can actually see what it looks like, and a close-up of the moon. Actually, there's a full moon out tonight, so when you leave, take a look. And we've also got our solar system. You probably remember from elementary science, maybe making a model of the solar system or seeing this chart. Well, I can tell you right now, that is not to scale in any way, shape, or form in either sizes of the planets or distances. is a rough approximate at most. So, making the stars also, that includes things like, next slide, this. All those points of light are stars. Every one of them. Some of them bigger than our sun, a lot of them about the same size as our sun, and some of them smaller. Let's talk about the sun for a second, our personal star. So, the greater light to govern the day, we can pretty confidently identify that as the sun. After all, that's the only thing you can see during the day. Well, except for when the moon happens to rise early. But otherwise, no question about that it governs the day. Now, the sun is the closest star to us. In fact, ancient astronomers didn't think that the sun and the stars were actually the same. They thought the sun was a totally different thing, made out of a totally different material. It wasn't until a little later on that some people started wondering, hold on, is the sun just a closer star? Or are the stars smaller or further away suns? It turns out, yeah, the sun's a star. It is 1 AU, or astronomical unit, away from Earth. So if you run across 3 or 4 AUs, if you look into stuff about the solar system, that just means that planet or that moon is so many sun to Earth distances away. Because if you try to use miles or kilometers, they get pretty meaningless when you get to 900 million kilometers. So, oh yeah, it is 1 AU is 93 million miles away from us. You could fit 1 million Earths in the sun. To get a sense of the scale, if you had a basketball-sized sun, the Earth would be the size of a BB. Its power is equal to 100 billion hydrogen bombs per second. But only 1% of that energy reaches us. And a lot of that energy is just deflected by our atmosphere. And light, the fastest known thing in the universe, takes 8 whole minutes to reach us from the sun. 8 minutes. So yeah, technically the sun you see right now is 8 minutes in the past. Now let's talk about our moon. So, it is the lesser light that governs the night after all, especially when it's a full moon. You can't really see the stars. It's kind of annoying. But sure is nice when you need to see outside. So the moon reflects the sun's light. It is actually 1/4 the size of Earth, which is the largest planet to moon ratio in the solar system. No moon is that large compared to its other planet, or compared to the planet it orbits. I'll talk more about the difference between what makes a planet and what makes a moon later. Now, craters caused by asteroids, as you can see all those little spots on it, because it has no atmosphere to protect itself. We would look like the moon if it were not for our sky. Yep. On the near or light side of the moon, it is 248 degrees on the surface. Yikes. Hotter than Arizona. But on the other hand, the opposite side of the moon, the one that's always in shadow, is negative 274. That's colder than Antarctica. Extremes. Its gravitational pull on the Earth is actually strong enough to pull the Earth's oceans toward it. That's what causes tides. And it's the only place in the universe other than Earth that man has ever gone to. And, in case you guys didn't know, there's actually a current mission program by NASA called the Artemis mission that they're actually working on, because the Apollo missions, were so long ago. Well, NASA has finally gotten on their game, and they're sending astronauts to the moon again, this time to establish a moon base. That's, I think, happening probably around the end of this decade. So watch the news carefully. You might have a moon base. We may have a moon base on the moon by the end of this decade. One step closer to Mars. That's the idea. So now, Earth. Our home. Now, Earth is the only place in the universe with life. The only place confirmed in the universe to have life. And the only place that has all the correct parameters, from being just far away enough from the sun that we stay warm, but not too far away or we'd be an ice ball, not too close or we'd be a fireball. All sorts of things that have to be just right. Liquid water, too. We have liquid water because we're in what's called the Goldilocks zone. Too close to the sun, water would boil away. Too far away from the sun, it'd be all ice. Now, interestingly enough, the Earth was actually made before the sun and moon, according to the account in Genesis. So the moon is the Earth, sorry. The Earth is, let me see, day 1, day 2, day 3. Yeah, the Earth is 3 days older than everything else. Which is interesting to think about, especially because in the evolutionary theory, a lot more things are way older than the Earth. And the Earth is actually one of the younger things in the universe. So, sun, moon, and Earth. Clock of the skies. So remember how it said in Genesis that God was putting the lights to act for signs and for seasons, for days and for years? Well, interestingly enough, your calendar and your clock are based on astronomical systems, even today. Continue. Yep, but they're signs and for seasons, for days and for years. So, what defines a day? One rotation of the Earth around its axis, so that one side gets exposed to the sun for about 12 hours, it varies depending on the time of year, and one side of the Earth is away from the sun for about 12 hours. That's a day. Interestingly enough, the hour isn't actually defined by any astronomical phenomena. People in ancient times just decided that 12 was the number to, that 24, a 24-hour day was just the number to go with. And so we've kept it ever since. Now, interestingly enough, a sundial used to be people's clocks for a good, until we got these little mechanical clocks. That's how people told time. You'd be out of luck if you had a cloudy day. And in fact, did you know that a sundial can actually be calibrated if, you get your location right, latitude, longitude, can actually be accurate to within 10 minutes. Yep. Continue. Oh, another thing. Why do clocks go clockwise? Because that's how the shadow would move on a sundial. It's a carryover. So, the month. Now, for many cultures, especially back in ancient times, the month was defined as the length of time it took from the moon from a full moon to a new moon, as it would go through various phases. Now, interestingly enough, our calendar does not follow the moon. It doesn't follow what's called a lunar month. Our months are actually just arbitrary divisions of the year. That's why on our calendar, if you were to try to use the moon to determine which month you were in, it wouldn't work. Because where the new moon and full moon lands changes month by month. But that calendar, a lunar solar calendar technically, is the one that we have. The Gregorian calendar is what most of the world uses now, including us. It wasn't until the medieval era that we actually got the calendar that we use today. And in fact, the Israelites, the Jewish people, they keep track of the festivals in the Bible, like Passover and Yom Kippur, by a lunar calendar. So in Israel, they actually have two calendars: the standard Gregorian calendar to keep up with the rest of the world, basically, and then a lunar calendar that they use to keep track of when the festivals occur. So, yeah, it's a bit of a complicated system, as you can imagine. And that's also why Easter changes its date every year, because Easter is actually tethered to a lunar calendar. So that's why it jumps around on ours. So how does the moon go through these different phases? Well, it's going around the Earth. And as it goes around the Earth and changes its position in relation to the sun, you see the moon has different amounts of light from the sun on its face. What you see as the dark part of the moon is actually the Earth's shadow. That's actually why back in even ancient times, most people knew, at least the ones who were like the astronomers, knew that the Earth was round. Because, I mean, people were smart enough to figure out that the only thing that consistently casts a circular shadow is a sphere. And the shadow on the moon was always a circle. That's one of the ways that they knew. So, the whole idea of ancients believing, in flat Earth, not true. Not true. Continue. And in fact, a Greek, way back when, actually figured out the size of the Earth to within a couple 100 miles. So the year is caused by how long it takes for the Earth to go around the sun. Now, that is still on our calendars, how long it takes the Earth to go around the sun. That's the year. Now, what's interesting is that how long it takes is actually 365 and a quarter days. That's why we have a leap day every 4 years. So, with all this combined, the Earth rotating every 25 hours, the moon going around the Earth every 27 days, rotating on its own axis also every 27 days, and that's why you always see the same side of the moon. And the moon and the Earth all going around the sun in 365 days. And oh, by the way, the sun itself turns every 25 days. That's quite the complicated clock, isn't it? Any theory that tries to explain just this system alone through in completely natural means has a very hard time explaining how these motions are so consistent year after year after year after year. Continue. And yet, we have our day, we have our month, we have our year. But what about the week? Well, turns out there's no astronomical measurement for the week. None whatsoever. You don't use the sun. You don't use the moon. You don't use constellations. You don't use stars. You don't use anything up in the sky to determine, there's going to be 7 days in a week. Yet, this occurs in cultures throughout the world and throughout history. Any time that archaeologists or historians know how long a culture's week was, it was within 7 days. Now, how do you explain that for any natural means? Why? Why 7 days? Well, this is, I believe, one of the biggest proofs for the 6 days of creation and the seventh day of rest. It's almost like it became in itself almost like sort of a universal law that man can't help but to uphold. For example, one time in recent history when somebody actually tried to change the length of the week, the French Revolution, the new French government tried to institute a 10-hour day and a 10-day week because metric system, base 10. It failed miserably. People just somehow couldn't adjust to 10 days as a work week. or 10 hours within a day. It failed utterly, ultimately. So everything else within France became some unit of 10 meters, kilometers, what have you, but not the week. The week went back to 7 days. So now let's talk about the solar system. The term solar comes from sun, so it's the sun's system. So this is the true size of the planets in the solar system. So from left to right, you've got itty bitty little Mercury, then you got Venus, then you got Earth, that little blue marble, then you got Mars, then you got Jupiter, which an Earth could fit within Jupiter's red spot. Then you got Saturn, then you got Neptune, Uranus, Neptune, and then itty bitty little Pluto, which technically isn't even considered a planet anymore. It's just a dwarf planet as of 2006, but a lot of people still put it in there. So as you can see, the Earth is not the biggest one in the neighborhood whatsoever. Now, remember what I said about how practically every solar system chart you see is not accurate when it comes to scale of size or distance? You can either have this chart, which is true size, or true distance. The sizes of the planets are not to scale, but the distances are. Look at that little cluster of Mercury, Venus, Earth, and Mars. Then Jupiter, then Saturn, then Uranus, which is 20 Earth to Sun lengths away. And then you get to Neptune, which is 30 Earth to Sun lengths away. Well, remember, it takes light 8 minutes to cover the distance of 1 AU. So how long does it take light to reach Neptune? A while. In fact, if I remember correctly, Pluto at 40 AU, it takes light a good leisurely, let's see, if 1 AU is 8 minutes, 8 times 40. 320 minutes for the light of the sun to reach little Pluto. That is well over 2 hours. Yep, to Pluto, sun just looks like, ooh, an especially bright star. It's incomprehensibly big. So, I've been mentioning a term a lot, planets. What are planets? Well, planets are any bodies that orbit stars that are big enough to look like a ball, basically. So the word planet comes from a Greek word meaning wandering star, because before we got powerful enough telescopes during the late 19th century, early 20th, the planets looked like little dots moving around the sky. They looked like the stars that wouldn't stay put month after month, year after year. All the other stars stayed in place, so to speak, but the planets, they kept moving around. So to the ancients, planets were just stars that kept moving. They didn't know they were something different until Galileo took a telescope, looked at Jupiter, and went, that's no star. So, what are planets? According to the International Astronomical Union, that's quite a name, it must orbit a star. So there are actually other planets that orbit other stars besides our sun. We call them, exoplanets. So yeah, there are lots of other planets out there besides the ones in our solar system, by the way. It must be big enough to have enough gravity to force it into a spherical shape. In other words, it must have a certain amount of stuff in it, or mass. And it must be big enough that its gravity cleared away, usually probably by assimilating, dragging it in, any other objects of a similar size near its orbit around the sun. In other words, we got no Jupiter-sized planets near Jupiter, for example. This is actually one of the reasons why Pluto is not a planet now, because astronomers discovered a Pluto-sized planet called Eris nearby. And they went, hold on. If there's this guy, then what about... And then they've discovered a bunch of other what are called now dwarf planets. They're not technically planets because they're all around the same size. So what are moons then? Well, moons are rocky objects that orbit the planets. They are a type of natural satellite. So for example, there is a moon that orbits Saturn called Titan that's as large as, I think it's as large as Mars. There's a moon the size of a planet, but because it's orbiting such a bigger planet, it's not a planet, it's a moon. So the moons, there's a whole ton of them out there, and they come in all sorts of fun shapes and sizes. So as you can see, our moon in comparison doesn't look nearly as fun, but it's special. It gets called moon. It's also the biggest moon in relation to its planet, at a quarter of the size of Earth. About the size of the United States of America, interestingly enough. So, comets are... So, I don't know how many of you saw the comet that came through a couple years ago called Neowise. I actually saw that comet one night. I just happened to look up and it was like, oh, there it is. They're basically space snowballs, balls of ice and rock that melt as they approach the sun, but they don't melt into liquid water. They subliminate like dry ice, and that's what forms the tail. Now, interesting note, and I'll be hitting this later, comets can only last thousands of years at most because every time they get close to the sun, they melt, they deteriorate. In fact, astronomers have watched multiple comets either crash into the sun, crash into Jupiter, or otherwise just disintegrate. So why do we still have comets? That's a question that needs to be answered, but all the evolutionary theories don't do a good job of answering. Now, they have these hypotheticals like, oh, maybe there's this Kuiper belt that has a bunch of comets in it. The problem is we've never seen the Kuiper belt, so we can't say whether that idea is a good one or not, and most likely. Anyway, there's lots of other evidences for why the solar system is actually young and not billions of years old, but we'll get into that later. But comets are one of the biggest problems that is not well addressed in any of the theories of how the solar system formed, other than God just made it that way only several thousand years ago. Now, asteroids are everything else in the solar system that's not a planet and not a moon. Even space dust is technically asteroids. They're just microasteroids. So it's called a meteorite if it falls on a planet, like Earth. A meteor, as it's falling down through the sky, also tends to be known as a shooting star. Now, they form pits or craters on planets or moons. Interestingly enough, people have tried to date planets and moons by how many craters they have on them. Like, okay, if this moon is this old, then it's going to have so many craters on it compared to this moon. It hasn't worked out too well when they've discovered moons that are so volcanically active, they're basically turning themselves inside out. So, there goes that idea of dating by craters. So, for example, check out that poor moon. That moon orbits, trying to remember, Saturn. That moon orbits Saturn, and yeah, that's a big old crater in the side. Makes it look like the Death Star. Makes you wonder how it even survived an impact of that size, but somehow it did. And you can see on Mars, there's lots of craters on Mars, because even though Mars has an atmosphere, it has a very thin one in comparison to Earth's. So, as you can see in this diagram as well, there's also the asteroid belts. The one between Mars and Jupiter, and then the one that is theoretically outside the solar system, the Kuiper belt. See? So, now let's talk about the two theories of how the solar system formed. So, the nebular hypothesis says 4.6 billion years ago, So 10 billion years after the universe came around, finally we have our solar system. As the sun formed out of a collapsing ball of gas as a star, the dust and ice around it began to orbit it. This dust eventually clumped together into balls that formed the rocky planets. Ice and gas further out formed into the gas giants. That's Jupiter, Neptune, Saturn, Uranus, Neptune. And the rest of the debris then settled into the two main asteroid belts. This sounds like a pretty good theory, right? Well, there's some issues with it, and I'm only going to go over a couple. But the big one is every computer simulation that they've ever done so far with this model in mind, basically the results go, well, Jupiter wouldn't exist, Mercury wouldn't exist, all these moons wouldn't exist, comets wouldn't exist. In other words, they keep coming out with solar systems in their computer models that don't look anything like our actual solar system. So I don't think that's a very good model. There's lots of other reasons there's issues with it too. Now, the creation theory, on the other hand, says, well, on the fourth day of creation, several thousand years ago, God just made it that way. He supernaturally made the planets and the moons any way he wished. He set the planets spinning and put them in their orbits precisely, specifically, for a specific purpose, especially in the case of the Earth and the Moon. And he also placed the asteroid belts in their specific spots. That's one theory. Another theory is the asteroid belts came along later because of other things, like perhaps the effects of the flood wasn't just on Earth. But those are more speculative. So, remember what I said about comets? They are the clock that makes it so that the solar system can only be a few thousand years old, up to tens of thousands of years old, but certainly not millions or even billions. Unless we can find a way that comets can make themselves or be created, this is a problem. Another problem is a moon like this. This is called Miranda. It orbits Uranus, and what is going on with this thing? When astronomers first saw it, they scratched their heads and went, what form of tectonics could create that? Well, some astronomers went, what if it was an asteroid impact? And not just one, but 5 of them. And the moon somehow came back together 5 times over. I think if an asteroid were big enough to shatter a moon, the moon would not be able to put itself back together. Especially 5 times over. It's very possible it was just made that way. Nobody has come up with a good natural explanation for why Miranda looks like somebody took a paintbrush and had a field day. Continue. I mean, there's cliffs on that moon that are 6 miles high. Imagine standing on the edge of a 6-mile high cliff. Another thing. So, you know how I said that the Earth rotates on its axis, right? Well, all the other planets rotate on an invisible line as well. Mercury is pinpoint accurate, super straight. Venus is a little straight. Earth is tilted. Mars is tilted. Jupiter is straight. Saturn is straight. And then Uranus is just over here like, okay, so you guys are all like tops. I'm going to be ball. It is completely on its side. And its moons even orbit it, completely contrary to all the other planets. The problem is, if all the planets formed out of the same dust gas disk, why are they not all in the same position? How is Uranus just do-do-do-do-do-do-do-do compared to everybody else do-do-do-do-do-do? Well, guess how many astronomers explain that one? Asteroid. Big asteroid bonked Uranus over. But then why didn't the moons just go whee or continue orbiting Uranus like all the other planets? the right way. Not a good explanation. And interestingly enough, just to note as to the cherry picking that does go on with what many scientists will tell you is, oh yeah, floods on Mars. They believe at one point, many evolutionary scientists believe, that Mars at one point was covered with enough water to have global floods and to cause like these boulders, these mega canyons, lots of erosion. But Mars today is a super dry place. It's a desert. Its atmosphere is so thin that any liquid water would just evaporate. Now, interestingly enough, it does have frozen water at its north and south poles, and there may be frozen water under its surface. Because of that, a lot of scientists think they'll also find life on Mars. But you need more than just water for life, especially when you're getting baked during the day and frozen at night. I mean, you thought the moon was bad. And yet, water covers 70% of the Earth's surface. And those same scientists that say that a flood happened on Mars will say that a global flood, like the Bible describes, never could have happened on Earth. So, I don't know. You gotta wonder, what are they oblivious or blind to because it would make the Bible look true? Just keep that in mind. So now let's talk about constellations or asterisms. So again, we're kind of going back to astronomy as it was practiced for thousands of years. And how did people even identify or keep track of stars in the sky? It was through these star groupings called constellations. So if you look at the sky with your naked eye or even with a decently powerful telescope, this is what you'll see. Big stars, little stars, planets look like stars. That's what people saw for most of human history. Interestingly enough, the Bible actually directly mentions constellations by name. Several of them. Who makes the bear? So you might know that as the Big Dipper is part of Ursa Major, or the Great Bear. Orion and the, let me see if I can get this right, the Pleiades, which is a star cluster or an asterism, a group of stars. Also known as the Seven Sisters. You've actually seen this star grouping on every Subaru license plate because Subaru is the Japanese name for that star group. And the constellations of the south. Can you bring out a constellation in the season and guide the bearer for satellites? So there has actually now been identified about 40 plus constellations that have actually been known since very ancient times. Job is the second oldest book in the Bible besides Genesis. So there's been lots of speculation as to why constellations are so old. How do people come up with these arbitrary names and these arbitrary groupings of stars that don't look anything like what they're supposed to look like? Lots of theories. One of the more probably prominent and accurate ones was that many of the constellations were invented at Babel, and then when people got dispersed, they carried the memory with them, and that's why you have the same constellations show up in cultures all over the world. For example, the pyramids of Giza, they're actually aligned with, if you were to look top down, with the stars in the belt of Orion. Like their very position, angle, whatnot, at a certain time of the year, they line up with the stars if you were to draw an invisible line from the top of the pyramid to the constellation. The ancients were actually very into astronomy. And because it was connected with their religions. keeping track of those constellations. In fact, right there is Orion. Orion's actually one of the easier constellations to see because it's got some very bright stars. Now, you might have seen maps like these. They're called star charts. They show you where all the major constellations are. And some of them even show you the difference between like summer and winter skies. Because with the seasons, what we see changes somewhat between north and south. Continue. For example, in the northern hemisphere in the winter, so basically right now, if you were to look north and the Grand Mesa wasn't in the way, this is what you would see, without the blue lines, of course, to help you see the constellations. So, if you're interested, there's lots of resources online, or even books you could get from the library. There might even be some books at the school that have these star maps if you want to start mapping out the night sky. In fact, sailors, explorers, they used to use these constellations to actually determine the direction they were going at night and navigate. And in fact, in the Navy, they still teach people how to do this in case their electronic systems go down. Continue. So now let's talk about stars. So, we have now identified within the past 100 years or so many different types of stars. Red giant stars, supergiant, yellow dwarf, red dwarf, brown, blue, white, all sorts of exotic names. It turns out every star that we've ever looked at is unique from every other star. When it comes to their brightness, their size, their composition, every star is unique, which is incredible to think about considering there are billions and billions and billions of stars. If you're wondering which category the sun is in this list, the sun would be close to a yellow dwarf star. Definitely not the biggest guy in the neighborhood. Now, this is a crazy... So remember how I said that planets can orbit stars? And we found what seems to be a lot of these planets called exoplanets? Thousands of them? Well, stars can also orbit stars. In fact, most stars we've discovered actually exist within binary star systems. That means two stars are orbiting each other in a complicated dance. This is just an example of a star system that they found where it's 1, 2, 3, 4, 5, 6 stars all orbiting each other. Man, how do they not all crash into each other by now? Continue. And that's not even getting into the strangest of the stars, the black holes. The stars that are so big and so massive and yet so small that they basically punch a hole in reality and light cannot escape. Now, we've never seen a black hole directly. By their very nature, we really can't. But they affect the universe around them in very grand and dramatic ways. In fact, we now believe, well, actually, let me clarify that. This, as of, I think, about 5 years ago at this point around, this is our first image with using radio waves of a black hole. More specifically, the disk of glowing, hot, super fast matter called the accretion disk around a black hole. So there you go, a black hole in the flesh, sort of. It's not just a theory anymore. It also helps explain how, for example, how do galaxies even stay together? And when we've measured the center of galaxies, a black hole is the only explanation. So yes, there's a black hole just chilling out in the middle of our own Milky Way. And this black hole is over 1 million times the mass of the sun, but compressed into a space smaller than the smallest star. Now, let's talk about nebulae. Nebulae are absolutely beautiful. Now, a nebulae are clouds of gas and dust that are lit up from within by stars. The term nebulae came from a Latin term meaning cloud, because back before we got powerful enough telescopes to see them, all astronomers could see were these dusty blobs. But now that we have telescopes like the Hubble telescope or the Webb telescope, we get these beautiful images like this one. Or the Eagle Nebula. The free, almost like pillars that make up the beak are also called the pillars of creation. Or how about these nebulae? Absolutely gorgeous. And the thing is, every single little dot in those pictures, stars. These nebulae are thousands of light years. That's the distance light travels, the fastest thing in the universe in a year. Thousands of light years across. Continue. Check this out from one of our newest telescopes. Every pinpoint of light, a star. Now let's talk about galaxies, the super big group of stars, or groupings. So the Milky Way galaxy, on a dark enough night, that's the galaxy that we're in, the solar system, Earth. And on a clear night, you'll see it as a milky band across the sky of a bunch of stars in it. What we're actually seeing is one arm of this. We don't actually know what our Milky Way galaxy looks like because we're in it. But we've studied other galaxies that are nearby, close to it, similar size, similar properties. So this is our best guess of what it looks like. We are a tiny little star within one of the outer arms. The sun is a tiny little star. So, there are an estimated 100 billion to 400 billion stars just in our Milky Way. If the Milky Way was shrunk to the size of North America, our solar system would be the size of a quarter. The size of the United States. Try to find a quarter on the road. But that is not all. Continue. There are multiple types of galaxies out there. Spiral or barred spirals, which Milky Way galaxy we think is a barred spiral galaxy. Spiral galaxies, irregular, peculiar, because it doesn't fit into any category. Elliptical, they look like oval football shapes. Most of the galaxies that we see are either spiral or barred, though. Continue. Now check out this picture. Remember how I was saying earlier that every point of light is a star? Not this time. Every point of light is a galaxy. This is the Hubble Deep Space Field image. They put the Hubble telescope on the same area of sky for several months over the course of multiple years. The area they were looking at would be the equivalent of me putting a dime out at arm's length. Just a teeny little speck of sky that they looked and they were like, okay, we found a completely blank area of sky. Our most powerful telescopes so far say that is completely empty space. Is it empty? They focused Hubble on it, the satellite telescope that you see a lot of the images on the internet from. And when the results came back, they were astonished to discover all these galaxies. So if a dime-sized worth of space that looked supposedly empty was full of galaxies, how many galaxies are there in the universe? Well, with more research, lots of guessing, this is kind of going into the territory of historical science in a way, because they're having to make a lot of inferences, but astronomers now believe, next slide, that there are as many galaxies in our universe as there are stars in the Milky Way galaxy. at least 100 billion galaxies. And each of those galaxies hold hundreds of billions of stars. I'm not even talking about the distances yet, though. Like, if the solar system fit in the palm of my hand, the next nearest star would be half a mile away. And the next nearest galaxy, the Andromeda Galaxy, to our Milky Way, would be all the way on the east coast. Solar system palm of my hand. Next closest star, half a mile away. Next closest galaxy, you'd have to go across the entire United States. No, absolutely not. So, yeah. So, when the Bible says, and God made the stars also, as an aside, understatement. The biggest understatement ever. Continue. So, every spot is a star. There are thousands of these nebulae within any galaxy. There are thousands upon... It just gets incomprehensible. I mean, there are clusters of stars that have casually 500 million stars within one group. Looks like you spread glitter all over the place. Continue. So, whatever cosmogony you have has got to explain that. A universe of that size, that many stars, that many galaxies. Every star unique, every galaxy unique. And our solar system, in the middle of it all, on little old Earth, that somehow is in the outer part of a galaxy, so we don't have a bunch of space dust between us and all the other galaxies. How convenient. So, as a reminder, a cosmogony is a theory of the origin of the universe. It's also the creation and origin of the world or universe. So, Big Bang or created? Well, there's a short video I'm going to show you talking about the Big Bang and whether it would in fact work out with, remember, Big Bang, historical science. Stars, galaxies, what we observe, observational science. Does the observational science confirm the Big Bang? Oh, my computer's muted. You're going to have to... Yeah, sorry, I muted the computer earlier. Have you got it? You may have to help him out there. What's going on? Why did the screen go dark? Oh. Here. There we go. It was just, earlier it was playing and it wasn't supposed to. That's why. Okay. Up. No. Well, that works. Just go back to where we are. Slideshow. Oh. There we go. Now, what was it that you did? Okay, on my TV, that's showing me. There we go. Alright, and then volume.
How did the universe begin? Some people say that it came into existence billions of years ago in a massive explosion, but this Big Bang has some big problems. First, the antimatter problem. Whenever scientists convert energy into matter, they get equal amounts of matter and antimatter. Antimatter particles have the same mass but opposite charge. Supposedly, the Big Bang converted energy into equal amounts of matter and antimatter, but the universe shows no sign of this expected antimatter. Second is the horizon problem. The Big Bang model says that the universe started out very small and rapidly expanded. This would leave huge hot and cold spots, since even a 13 billion year old universe is still too young for temperatures to level out. But the actual universe shows temperatures remarkably the same in all directions, no hot or cold spots. Mature galaxies pose a third problem. Light from the farthest galaxies we see supposedly took billions of years to get to Earth. So those distant galaxies should still appear undeveloped and chaotic, as they would have after the Big Bang. But distant galaxies look fully mature, not haphazard like the Big Bang predicted. Even the very distant regions of the universe reveal galaxies of magnificent beauty and complexity. In addition to these scientific problems, the Big Bang contradicts the Bible. The Big Bang needs billions of years, but God's Word describes the beginning of the universe happening in just 6 days only thousands of years ago. The Big Bang teaches that the sun and stars formed before the Earth, but the Bible says the opposite. Not by some problem-riddled explosion, but by the word of the Lord the heavens were made, and all the host of them by the breath of his mouth.
There's a lot more issues with the Big Bang than that brief video just covered, but those were the big ones. And by the way, that antimatter-matter problem, we basically would have equal amounts of protons that acted like electrons and electrons that acted like protons, and even, theoretically, parts of the universe would have gravity working backwards. But, interestingly enough, you know what happens when scientists make antimatter and matter? Within less than a split second, it's like, oh, you're not supposed to exist. The matter will annihilate the antimatter and everything's right again. So, the problem is, if the Big Bang really happened and it produced all this matter and antimatter, why did it not basically just destroy itself right after it started because of all the matter and antimatter coming back together? You would have had a big whoop, basically. All right. Now, another short video that I have, so go to the next slide. We'll go more into how the solar system can't be 4 billion years old. Okay. Thought we had the videos figured out this time. Let's see what's going on. Oh, it could be because it wasn't technically on the slide anymore. It was like on the actual video, perhaps. All right. Yeah, and don't click on the video. I think that's part of the problem. Instead, when I move the slide, it automatically plays. So that might have been part of it. I don't know. I don't know why that keeps showing up.
Just how old is the universe? Well, it doesn't have an expiration tag, but we can make some estimates by looking at things in our universe, like the moon. As the moon orbits the Earth, its gravity pulls on the oceans, causing tides. And as the tides pull on the moon, they cause it to move about 1.5 inches away from the Earth each year. That means that 6,000 years ago, the moon would have been about 800 feet closer to the Earth. Not a problem. But if the Earth and moon were over 4 billion years old, then they would have been touching, and that wouldn't have been good. So the moon shows that the universe is several thousand years old. That makes sense when we also look at comets. They lose large amounts of material each time they pass around the sun, so they wouldn't even be around after billions of years. And the inner regions of spiral galaxies rotate pretty fast. If the galaxies and the universe altogether were billions of years old, they'd be too twisted up to look like they do now. So everywhere we look in the universe, we see evidence that shows that what the Bible says about its age is consistent, and that the heavens really do declare the glory of the Lord.
So, if you want to find out even more evidences for why the Big Bang doesn't work, for why the nebular hypothesis of the solar system doesn't work, and why everything's a lot younger than most of your astronomy textbooks will tell you, there's a great video series called What You Aren't Being Told About Astronomy. Each volume is over 2 hours. He has one just on the solar system. And I tell you, the big conclusion of that presentation is over and over and over again. Moons are too young. Planets are too young. They're too hot. They should be old, cold, and dead if they're 4 billion years old, but they're not. They're releasing energy. They're hot. They're tectonically active. You've got volcanoes, active volcanoes, including a moon that's erupting so frequently that if it really was 4 billion years old, it would have turned itself inside out 5 times over. It doesn't make sense. And then you got the young sun paradox, what's called. The sun should be way bigger than it is now, way hotter if it was really 4 billion years old. Anyway, lots and lots and lots of issues that I don't have time to go into tonight. But if you want to find out more, I can direct you to resources. So, why does this matter? All of this. Well, if you can't trust what the Bible says in the first verse, or the first chapter for that matter, then why should you trust the rest of what it has to say? It's as simple as that. If I told you earthly things and you do not believe, how will you believe if I tell you heavenly things? If the Bible, Christians, in a sense, can't get it right when it comes to earthly things like science, and why would we be right about the much more, things we can't see or experiment with? Continue. Many people think creation is just a religious myth. Evolution is science. The Big Bang is science. The nebular hypothesis is science. Continue. But both are historical science. Both can be used to interpret the data. We're dealing with the same Earth, same moon, same stars. And both require faith. Continue. Evolution requires faith in time, chance, and natural processes. Somehow an explosion created those galaxies and our solar system. Evolution is not, arguably, even a good historical science for that matter. It's a philosophy posing as science. But it is the pillar of the naturalistic worldview. A worldview that says the physical realm is all that there is. The physical laws, the universe, that's it. Nothing spiritual, no God. Continue. Naturalism says that everything in the universe can be explained by only natural processes without a God. No room for miracles or supernatural creation here. Even if all the data points to an intelligent designer, whether it's in biology or in the universe, such a hypothesis is excluded from science because it is not naturalistic. Number one reason college students give for not responding to the good news of the gospel is because they think evolution has proven the Bible to be wrong, false. So, stand firm on God's word, and, well, if you hear anybody trying to say that, the Bible can't be true because of this scientific fact, look at it a little closer. It may be just an idea, a story, presenting itself as science. But if you think about it, it's really convenient to go, we're the only ones that are free agents in this universe. We can do whatever we want. So, I know we ran somewhat over time. We did get started a little late, too. So if any of you need to go, you can. But if you're willing to stay for a little while longer, I have some bonus features, if you'd like. So, otherwise, thank you for coming. This presentation and all the other presentations I've done and will do are being offered for free, no charge. So, if you would like to support me or the ministry I work for, this is how you can do so. Otherwise, any questions, comments at this point? Yes, Kate. So 10 to the power of 24 stars in the universe then? Yep. According to, I don't remember the exact psalm, but yes, the Bible does say that God calls the stars by name. He calls out the starry host. Yes? Mm-hmm. Yeah, the geocentric theory? Yeah. Well, the reason they used to believe that is because we're on Earth, everything seems to rotate around us, so it made sense. The problem is that as they kept discovering new things, like new planets, they had to keep adding stuff to that theory, and it got more and more and more and more complicated until finally one day somebody went, well, what if we just put the sun in the center of it? Then it becomes a whole lot simpler. Pretty soon, other scientists discovered that, well, he was right. Yes? Mm-hmm. Yeah, the Mariana Trench is pretty deep. Yes. Yep, that's the reason why a year is actually 365 and a quarter days. So that's why we have to add a leap year every 4 years, or leap day every 4 years. There used to be leap years or leap months added. You could imagine how much harder that was to deal with. Yeah. I mean, that's what the Jewish people do. Every 4 years, they add another month. We just add another day. But that's because their months are shorter than our months, so their calendar's different. Yes? Oh, what if you could go into the sun and still stay alive? Well, it'd be like being in the middle of the hottest furnace ever. You wouldn't be able to see a thing, hear a thing. It wouldn't be very fun, because you wouldn't. It would be like if you're standing in the middle of the hottest furnace ever. Or actually, are you familiar with like the atomic bomb? It would be like if you were standing in the middle of a bomb that was 1,000,000 times bigger than the biggest one you could ever imagine. Mm-hmm. Oh, what if the moon were the size of this building? You wouldn't be able to see it at all. It would look smaller than the smallest star. Yes? Well, actually, you wouldn't have a big hole. The Earth would splinter apart. You'd have no Earth left if the moon were to crash into it. And you'd have no moon left either because of the force of the impact. Yes? Okay, 2 more things. Yeah, occasionally meteorites get through, or asteroids technically, get through our atmosphere and land on the ground as meteorites. Fortunately, they don't tend to be much larger than this, because otherwise we'd be having some serious problems, like a crater size problem. Mm-hmm. Yeah, that's probably the phase of the mission where they're actually getting man onto the moon. At this point, they're in the second phase where they're working on getting astronomers to go around the moon again. So they're actually in the middle of that right now. So that's the Artemis project, as a reminder. That started in 2020. Again, you have to see how the schedule goes. There was a telescope that was supposed to have gone up into space in 2018, and it took until 2021. So, yes. So the second phase then? All right. Yep. Yep, those 7 people will go out, go around the backside of the moon, and then come back. Really what they're doing is testing out their systems. So... And I think that's also... No, it's not the first time they've had man go to the far side of the moon. It's just the first time since the Apollo program, which was a long time ago. So. Alright. Well, as I said, again, if you need to go, you can go. But otherwise, let's go to the bonus feature. So remember how I said that a cosmology isn't just the story or a story of how the universe formed? It's also a description of like the structure of the universe? Well, if you interpret that from a biblical perspective, there's some very interesting connotations. Yeah, it's late. You're welcome. Alright. So hopefully I can get my clicker to work this time. Let's see. Huh. So, presentation number 2. God, the foundation. Math, the tri-universe, and space-time. So hopefully, for the younger kids in the room, this will still be understandable. But if not, it's okay. I am going over some pretty high-level concepts. And also, thanks, Kate, in case the clicker continues to not cooperate. I'm going to have to figure out what's going on here. Maybe it's weak battery. Okay, Kate, next slide. All right, so remember, cosmology is also a branch of astronomy that deals with the structure and space-time relationships of the universe. Now, why am I talking about space and time like they're the same thing? Well, you'll find out. Next. That's a blank slide. Why is it a blank slide? Oh, that's why. In the beginning. Next. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him nothing was made. John 1:1-3. Have you ever noticed that the first verse of John actually reflects the first verse of Genesis? In the beginning, God created the heavens and the earth. That was very intentional on John's part. By faith, we understand that the entire universe was formed at God's command, that what we now see did not come from anything that can be seen. Hebrews 11:3. So what does this mean? It means the universe was not formed by anything in the universe. So that invalidates anything like the Big Bang, just out the window. In like church theology, it's the idea that God created everything out of nothing, ex nihilo. Continue. Now, also in the beginning, unless we went backwards. He, Jesus Christ, is the radiance of the glory of God and the exact imprint of his nature. Pay close attention to this. He upholds the universe by the word of his power. Wait, he didn't just create the universe by the word of his power? He upholds it by the word of his power? What does that mean? Keep going. So, you're familiar, should be familiar, I think, with the 6 days of creation by now, right? Especially those of you that have been here for the past number of months. Well, let's take a closer look at day 1. From the beginning, now, this I think, depending on your translation, this verse comes out in many different ways. But in this case, I think this is one of the most interesting versions I've seen. It's called, from a translation called The Voice. From the beginning, creation in its magnificence enlightens us to his, God's, nature. Next slide. Creation itself makes his undying and divine identity clear, even though they are invisible. Wait. The universe makes its power clear, sure. I mean, I just talked about how incomprehensibly big the universe is. But makes his divine identity clear? Some translations will say creation itself continue. Try to remember if it was this one or another one. There's other translations of that verse that will actually say that creation reveals the divine Godhead. Well, the idea that I'm about to present to you is that God's attributes are reflected in creation. There are not exact copies or duplicates, just like a footprint in the sand is not a copy of the person that made the footprint. But the footprint does tell you that someone was there, and that someone was a certain size, probably a certain height. Sometimes they can determine whether it was even like a male or female footprint. Lots of things can be told about a person through their footprint or their fingerprint. Everyone has a unique fingerprint. If you know the fingerprint to the person, the fingerprint can tell you a lot about a person. Same thing here. The idea is what I'm about to show you is some of God's footprints or fingerprints within creation. Continue. So, let's talk about the Trinity for a second. That all-important concept that yet we just can't get our heads around, because how in the world can God be three in one but not be three gods? What? How does this work? How can God be the Son and be the Father and be the Spirit, but the Son is not the Father and the Father is not the Spirit and the Spirit is not the Son, as this diagram shows? How can that be true? Well, let's look at a minor reflection of a structure of three within creation, the creation week. Day 1, day 2, and day 3. You got separation of light, dark, separations of waters above and below, separation of land, waters. Next 3 days, you have day 4, which puts things in the light and the darkness. You got day 5, which puts things in the water above and the water below. And you got day 6, which puts things on the land. So already right here, we have a very unified structure even within the days of creation. How is that? Next slide. See, day 1 set up day 4, day 2 set up day 5, and day 3 set up day 6. Pretty neat, huh? Even the days had a very purposeful order. But if you really want a true reflection of the Trinity in nature, it's got to be something that is made up of multiple distinct things that yet are made up of the same thingness. Just like how God is Father, Son, Spirit, but the Father is God, the Son is God, the Holy Spirit is God. Same thingness. Continue. Now, let's talk about the universe for a second here. Let's talk cosmology, the structure of the universe. Well, the universe is made up of time. According to modern physics, the universe is made up of time, space, and matter energy. So matter energy is like all the stuff around us. Space is what matter exists in, and time is what everything is moving in, sort of. Lack of a better word. Continue. The universe could not exist without any of these components. You gotta have space or you have no universe. You gotta have time or you have no universe. You gotta have matter energy or you have no universe. And yet, space is not the universe. Time is not the universe. Matter is not the universe. But you cannot separate space, time, and matter from each other. They are connected. They cannot be separated, yet they are three distinct things within the same thing. It is a universe of these three things. Continue. So, how's that for a correlation? It gets better. So, let's look at day 1, Genesis 1:1. In the beginning, God created the heavens and the earth. Ooh, interesting keywords. Beginning. Can't have something begin without time. Heavens. Space. Next slide. And earth. Matter, energy. Next slide. So, arguably, the very first verse of the Bible states that God made time, space, and matter. Boom. Set the table before he even started doing anything else. Which makes sense. You gotta have a universe to do stuff in it. So, yep. In the beginning, time, the heavens, space, the earth, matter. Genesis 1:1, he made the universe. Yep. Now, let's talk about space, time, and matter. Now, why do I have a hyphen between space and time? Well, it's because space is 3 dimensions. You know, you measure things by their height, their width, and their length, right? It's how much space they take up. But everything actually exists in these 3 dimensions called space. Time, scientists have discovered, is actually a 4th dimension of the universe. You cannot actually measure anything without taking into account its time. In a way. It either existed in the past, it exists now, or it will exist. It either exists for a second, it'll exist for a day, or it'll exist for 100 years. Time is the essential element, but it gets even stranger. It turns out when space is affected, time is affected. And gravity is our perception of that warping of space-time. When I drop something, I'm not going to drop this, but when I drop something, that's actually space getting affected. And time actually gets affected too. So you might go, well, what do you mean time gets affected? Well, this is the oversimplified explanation of a series of laws, theories called Einstein's theories of relativity. But hopefully this will make a bit more sense as to how space, time, and matter, they're all like connected together. You can't pull them apart. Continue. So, this is an example of the way that scientists think of gravity. They believe that everything that has mass, everything that's made up of atoms, like me, you, the earth, it creates a well or a divot, a pulling in space-time. which means I technically have a gravitational field. You do as well. You're just so small that nothing will orbit you, not even dust particles. If you were as big as the Earth, though, you'd have things orbiting you. So gravity is very weak on a small level, but it's exponential. The more mass you have, the greater the gravity gets, and it keeps going up and up and up and up. So that's why gravity is what keeps the solar system together. It's why everything orbits the sun, is because of gravity. So in this example, you can think of it kind of like marbles rolling around a well. The moon is a smaller marble going around a bigger marble. Now this is a two-dimensional representation, so it's not really realistic as a model in the sense of the way the universe actually works. On the other hand, that three-dimensional model with the little white ball is a little closer to what it would look like if you could see space-time with your eyes. Next slide. So gravity is the warping of space, as I said earlier. So you can imagine these cubes as like, units of space. And the space that's closer to the marble is compressed or pulled in compared to other space. And anything that happens to get close enough to the marble will just slide in. Continue. Because remember, nothing exists outside of space. But it also is the warping of time. So, next slide. If you look at this slowly rotating cube, I don't know how well you can see, but look at the little clocks on the corners. Look at how fast they're spinning around. But then look at the clocks around the middle. Look how slow they're going. That is an oversimplified representation of something called time dilation. The further away you get from an object like the Earth that has a strong gravity, the faster time moves. How does that work? It just does. And I'll tell you how. So if you look closer at this diagram, you'll see high gravity equals slow time. Less gravity equals fast time. This is called time dilation. So theoretically, if you could manipulate gravity on a very large scale, you could time travel. But it's on a very, very, very large scale, though. But GPS, good old GPS, is actually an example of how this isn't just strange theory. It's reality, and it affects us. So, GPS, warping of space-time in action. So whenever you use like Google Maps or you have the GPS in your car, if you really think about it, isn't it incredible how Google Maps can actually get you to your friend's house? How civilian GPS can get you to within 30 feet of a point, and military GPS can get within centimeters of a point, and that's over the entire globe. That's pretty incredible, right? Well, how does that even work? Well, you have these satellites orbiting the Earth, and satellites in this case are artificial, man-made satellites. Now these satellites, they orbit so high and so fast around the Earth, they're going around the Earth once every 12 hours. So they're moving twice as fast as the Earth is moving on its own axis. But because of that, you have about 4 satellites visible within the line of sight of any point on Earth. So that's how your car GPS can work. Because each satellite, it takes... So you got these radio waves that go from the satellite to your phone, and then your phone sends a signal back, and the satellites go, oh, okay, so I'm here, and you're there, and you're here, and it took this long for the radio signal. Oh, you must be here. That's the really oversimplified explanation. It's, if you've done triangulation, it's something similar to that. But remember how I said about how these satellites orbit really high and really fast? Well, they happen to be far enough from the surface of the Earth. Because remember, as you get further away from an object, the gravity of that object lessens. the satellites, the clock on the satellite and the clock in your GPS on the ground, in your car, in your phone, do not, next slide, tick at the same rate. The clock on the satellites actually run slightly faster than a clock on Earth. So, these satellites have to take into account this time dilation, or the satellites would be off by 6 miles per day. Those satellites, you put them up there in space, within just a couple of days, they'd be useless. So, yeah, to those satellites, time is moving faster. The clocks go faster in comparison to on Earth. The astronauts on the ISS, it going around the International Space Station, it goes around the Earth once every 90 minutes. They're technically aging slightly faster than people on Earth. It's just so slight that it's really undetectable. The only reason that we even know this is a problem with the satellites is because their clocks are so hyper accurate that we can even tell the difference, and it even becomes a problem. So yeah, this is observational science in action, even though it seems like it's something that shouldn't be real. Continue. So, this is hypothetically what it would look like if you could see a marble traveling through space. It warps space around it. And then add in time into there, and it gets all sorts of complicated. Continue. So, I'm going to show you a couple of minutes from, just click on the next arrow, Kate, don't click